Did you know that the first internal combustion engine was built in 1807 by Niels Niepce, long before the automobile made its debut? This rudimentary design, fueled by a mixture of moss, coal dust and resin, was a far cry from the engines we know today, but it laid the groundwork for what was to come. Niepce's engine operated on some basic principles that are still in use today. Fuel was ignited in a confined space, creating pressure that drove a piston, transforming chemical energy into mechanical motion. Over time, other inventors added their contributions to this foundational concept. Samuel Brown, for instance, leveraged the power of steam to refine the engine design, while Etienne Lenoir created the first practical internal combustion engine that used gas as a fuel source. While these early engines were far from perfect, they marked the beginning of a revolution in transportation. As the 19th century rolled on, the combustion engine began to evolve, giving birth to the engines we are familiar with today. This period saw the development of two key engines that would go on to shape the automotive industry: the four-stroke engine and the two-stroke engine. Nicholas Otto, a German engineer, is credited with developing the four-stroke engine, also known as the Otto cycle, in the late 1870s. This engine operates through a sequence of four primary steps: intake, compression, combustion, and exhaust. In the intake phase, the piston moves down the cylinder, drawing in a mixture of fuel and air. The piston then moves up, compressing this mixture in the compression phase. This is followed by the combustion phase, where a spark ignites the compressed mixture, causing it to explode and push the piston down. Finally, in the exhaust phase, the piston moves up again to expel the burnt gases. Around the same time, Carl Benz, another German engineer and the founder of Mercedes-Benz, developed the two-stroke engine. Unlike the four-stroke engine, the two-stroke engine completes the same four operations in only two strokes of the piston rather than four. This makes it lighter, simpler, and more efficient in terms of power-to-weight ratio. However, it also tends to be noisier, less fuel-efficient, and more polluting than its four-stroke counterpart. Both these engines had a profound impact on the automotive industry. The four-stroke engine, with its efficiency and power, became the engine of choice for most cars, while the two-stroke engine found its niche in smaller vehicles like motorcycles and scooters because of its simplicity and power-to-weight advantages. These advancements in engine technology didn't just make cars faster or more efficient. They paved the way for the mass production of automobiles, making them affordable and accessible to the average person. It's safe to say that the world as we know it would look very different without these groundbreaking innovations. These advancements in engine technology paved the way for the mass production of automobiles, changing the world forever. Fast forward to the 21st century, and the combustion engine has undergone significant changes. Let's delve into the world of modern combustion engines. Here, innovation is key, and technology is the driving force. The heart of this revolution lies in three main advancements: fuel injection, turbocharging, and variable valve timing. These developments have not only enhanced engine performance but also significantly improved efficiency. Imagine a time when we relied on carburetors to mix air and fuel for combustion. Fast forward to today and we have fuel injection systems. These systems allow precise control over the amount of fuel delivered to the engine, resulting in better fuel economy, improved engine performance, and lower emissions. It's like having an intelligent assistant, ensuring that not a drop of fuel is wasted. Then, we have turbocharging, an ingenious way of harnessing wasted energy. In simple terms, a turbocharger uses exhaust gas, which would otherwise be wasted, to spin a turbine. This, in turn, forces more air into the engine's combustion chamber, allowing it to burn more fuel and produce more power. It's like getting a power boost without burning extra fuel. Turbocharging has been a game-changer, giving smaller engines the power of their larger counterparts. Lastly, let's talk about variable valve timing. In the past, the timing of the opening and closing of the valves in an engine was fixed. Now we have systems that can vary the timing based on the engine's speed and load. This innovation results in better engine performance, improved fuel economy, and reduced emissions. It's like having a dynamic orchestra conductor, adjusting the performance to create the most harmonious output. These advancements are not just mere tweaks or upgrades. They represent a paradigm shift in how we approach combustion engine technology. They have allowed us to extract more power, achieve better fuel economy, and reduce emissions, all while using the same fundamental principles that powered the first combustion engines. Thanks to these innovations, modern combustion engines are more powerful and efficient than ever before. But what does the future hold for the combustion engine? As we look ahead, we see a landscape that is rapidly changing. Environmental concerns are mounting, and the rise of electric vehicles is challenging the dominance of combustion engines in the automotive world. However, it's not all doom and gloom for the beloved combustion engine, far from it. In fact, engineers and scientists worldwide are striving to make combustion engines cleaner and more efficient. Let's delve into some of these exciting developments. A key player in this ongoing evolution is the hybrid system. Hybrid vehicles use a combination of an internal combustion engine and one or more electric motors. This clever combination allows for the flexibility and range of a combustion engine, while also benefiting from the efficiency and environmental advantages of electric power. It's a win-win situation, and it's a trend we're likely to see continuing in the future. Another fascinating development is the exploration of alternative fuels. Take hydrogen, for example. Hydrogen combustion engines produce only water as a byproduct, making them a potentially eco-friendly alternative to traditional gasoline or diesel engines. While there are still significant hurdles to overcome, such as hydrogen storage and production, the potential for a clean, renewable, and efficient combustion engine is tantalizing. It's also worth mentioning that combustion engines are not just about cars. They're used in a multitude of applications, from ships and trains to power generators and industrial machinery. These applications present their own unique challenges and opportunities for innovation. So where does this leave us? The future of the combustion engine is a complex tapestry, woven with threads of innovation, adaptation, and resilience. It's clear that the combustion engine won't be disappearing anytime soon. Instead, it's evolving, adapting to the changing needs of our society and our planet. Despite these challenges, the combustion engine continues to play a crucial role in our lives, and will likely do so for many years to come. As we navigate the road ahead, it's exciting to imagine what the next chapter in the story of the combustion engine will look like.